coming to you with a compare of the quotient of two. Both quotients have large, what do we got here? 6-digit numerators and 6-digit denominators. So we want to know which one of these is larger. And of course, you don't want to use a calculator. That's no fun. I doubt that you guys want to do long division on this either. So now, first thing to notice, I guess, is that right there you got 78, right? Over here you have 80. Notice that these first digits agree, 6, 2, 1, 4, 5. All right, 6, 2, 1, 4, 5 over here. And then we bump this one up by 2. It's 78 plus 2 is 80. All right. So with that alone, you would say, okay, no brainer, the right-hand side is larger, right? You increase the value of the numerator by 2. But notice that we also increase the value of the denominator by 2, going from 29 to 31. Okay, so remember, everybody knows that if the numerator remains fixed and you increase the magnitude of the denominator, that makes it a smaller number. All right, so what we're going to do right here is look at a sort of a simple way to approach this without having to do any nasty computations. And so what I did here, folks, is this is one approach. I'm sure there's others, but I like this approach. What we did is we just let A be equal to this. All right, we let A be equal to the numerator of this fraction. Whoops, let me do that. Should if it doesn't. Okay, good. Now y'all notice here I just chose A to be equal to the numerator of this fraction, and I also chose B to be equal to the denominator of this fraction. All right. Now that turns it into a nicer looking algebraic expression because both the numerator and the denominator were bumped up by 2, right? Just as we just demonstrated. So this fraction on the right is equal to just A plus 2 over B plus 2. Now, if you take the difference of two numbers and get a positive result, that means the number on the left was the bigger number, right? If you take the difference of two numbers and get a negative number, that would have meant the number on the right is a bigger number. Okay, so that's really what we're employing right here. So to determine which fraction is larger, we actually consider the difference. And you know, it's horrible to write this out, but if you write it out like this, it looks much more tractable. Okay, now so what we have here is a pair of fractions that combine to give you a single fraction using common denominator. I did B plus 2 times A to give me these two terms right here. And then just the other way around, this B right here times A plus 2 to give me these remaining two terms. Now notice here you get some nice cancellation here. The AB's cancel. Those two massively large numbers cancel out. A and B cancel out. And you end up, if you factor a 2 out, you get this piece right here, 2 times A minus B. Now, so you might ask, well, why is this less than 0? Well, you can see that A is this number, right? A is this number. Let me write this down. This is I'm doing too much talking. Right here, folks, A minus B, since A is equal to this value right here and B is equal to this value right here, I'll write it right up here just so we're next to the numbers that we're talking about. A minus B is certainly less than 0, right? Again, and I have it written right next to the numbers so I don't have to write them down again. 6,214,578 minus 7 million something is going to be less than 0, right? Now, notice right down here, this bottom piece is definitely positive for our choices of B. And A minus B is negative. That makes the entire fraction negative. But notice that makes this entire part right here less than 0. Okay, this part that I'm hovering over right here, folks, that makes this object less than 0. But that means that if you add this to both sides, you get A over B is less than A plus 2 over B plus 2. And you get that the number on the right was the larger number. Okay. Y'all, I would invite you to do the decimals on these. That it's incredibly close. If you do the decimal of this and the decimal of this, they agree up to like the 70th million place, 70 1/1,000,000th place, something like that. It's the decimals is like just like the digits agree with each other, the decimal values, the decimal expansion agrees with each other all the way out to like 7 or 8 places. Anyway, I hope this technique, it has a name. You just take the difference of the two quantities you're interested in and you check to see if it's positive or negative. That's all that's going on here. And sometimes you don't get algebra that's easy to work with. But in any event, I hope you guys like that. Let me know if you have any questions or if you have problems like similar to this you'd like to see work. All right, thanks for watching.